All right, if everyone's ready, we'll get started. So thank you to everyone for sticking around for these last two presentations. We're really excited to present to you our Capstone project, Dell EMC, Storage Replication and Disaster Recovery. I'm Nikki Ruff, and I'm the team lead and storage specialist.
I'm Ben Kaboshek, the server administrator.
I'm Will Snisler, the virtualization specialist.
And I'm Riley Mueller, the project manager. We just want to give a special thank you to all of our sponsors at Dell EMC. Steve, Mark, Jake, Max, and Jacob all really helped us with this project, and as well as Cyrus, who stepped in when we needed him to help us troubleshoot some different networking issues we were seeing. Just to go over some of the different things we're going to talk about during our presentation today, we'll first go over some of the different acronyms we're using throughout our presentation to give you guys a background on those when they're used later on in the presentation. Then we'll introduce you guys to what exactly disaster recovery is, go over our problem statement for this project, move on into our initial setup of all of our devices, then show you our proof of concept, move into our live demonstration, then wrap it up with the conclusion on how we're able to meet the needs of the project, and then wrap it up finally with some different challenges and lessons we learned.
So to kick it off, we're going to go over some common acronyms we're going to be using throughout our presentation. The most common one you're going to hear is SAN, which is a storage area network. We're also going to be saying iSCSI a lot, which is a protocol, along with fiber channel, which you will see represented as FC on the slides. HBA is a host bus adapter. RPO is recovery point objective, and RTO is recovery time objective. And for this project, we've been given an RPO of 15 minutes and an RTO of 10 minutes. This means the amount of data lost cannot exceed 15 minutes, and the time it takes for this to fail over must be 10 minutes or less. So let's meet Kersnuffles Inc. They're a company offering a premium hosting platform for their customers. They provide each customer access to their own environment, which is segmented off from other customers for security. Kersnuffles' #1 goal is to provide data availability for their customers.
So if the customer's hosting environment goes down, or even if just a part of it goes down, and there's no recovery plan in place, then some real consequences can occur. The customer will start to lose money and trust from their clients. Valuable time becomes wasted. And most importantly, their customers lose access to the data that they paid to have access to. Many times disasters are unavoidable, but how can you mitigate this loss? Simply by having a disaster recovery plan. Because when a natural disaster such as a fire tornado is heading right toward you, you just don't have time to back up all your data.
So the Dell EMC team has tasked us with designing and installing a storage replication disaster recovery solution that fulfills the needs of Kersnuffles Inc. To meet these needs, we have a couple key parts to assemble: server and storage failover, replication between sites, customer VMware credentials for vCenter access, security features to protect customers from the outside world, and a recovery point objective of 15 minutes and a recovery time objective of 10 minutes.
There are a few business goals that the customer will achieve from this new hosting environment. First of all, with the upgrade, they can now fulfill the high expectations of their customers while maintaining a very minimal downtime. This will help the customer retain their current clients as well as grow their business as well. The customer has also reduced unnecessary costs and overhead, and is now able to improve their clients' overall experience and be able to offer services that they could not provide in the past. There are also some technical goals that the customer has achieved. They're now able to provide very high availability for their network and services. The implementation is also very scalable, so the customer can easily expand their network as they gain more users. And ease of management was made a priority, as well as security to implement or to separate customer traffic.
So before we move into some of the more technical aspects of our solution, we want to provide you some background information about a SAN. The storage area network is a device used to store and secure data across a high-speed network. Volumes are created on the SAN as a shared pool of storage. The servers then access the data through a back-end fabric. For this project, we used fiber channel and iSCSI as those back-end fabrics.
Now we'll move on to our initial setup. Some of the hardware that was donated by the Dell EMC team includes the following: 2 ST7020s for our SANs, 4 PowerEdge R630s as our servers where our VMs will be stored, and Broadcom Brocade 6505s for our fiber channel on Site 1, a Dell S3048 on, and 2 S4048s. Dell has donated a lot of devices, but these are the devices that we are using in our project. The overall design is essentially mirrored between the two sites. The S3048 is acting as our internet, where we will add traffic shaping and induce the 50 milliseconds of latency as required by the statement of work from Christoffels. Production site is using the fiber channel, as I said before, for high-speed throughput, and this disaster recovery site is using 10 gig Ethernet for acceptable speeds in the event of a failover.
Diving deeper into our setup, this topology shows our logical LAN design for our production site. This site is running fiber channel as a SAN fabric between the servers and the SAN, as Will said. The SAN has the ability to run both fiber channel and iSCSI protocols. And as you can see, the SAN also does have built-in redundancy with an identical top and bottom controller connected to each of the switches. It should also be noted that although we are planning for a disaster to occur, there's plenty of redundancy implemented on this production site that it should never have to occur. We will now be beginning our live demonstration as it will take some time to complete the failover process. We'll start by showing you that the production site is currently up, and then we'll run our recovery plan. And just to keep in mind throughout our live demonstration, the production server ends in 99.4, and the disaster recovery server is 99.11, and you'll be able to see that in our URL, which we'll show you. So this is our production server, and as I said, it is 99.4. We have our Windows Server live demonstration virtual machine here, and it is powered on, as noted by the green play button. If that green play button was not there, it would be powered off. So we're going to click on this real quick, and Riley will explain what's going on.
So here you can see we have our university program video that is running in a continuous loop. We'll show you that this data is on the disaster recovery side by the fact that we're able to start this video back up once the failover occurs. This can just play until it'll stop, and then we'll be able to pick it up at the beginning in the disaster side.
So we'll jump over to our disaster recovery server here. Again, it's 99.11. You can see this Windows server is powered off. There's no green button. It is currently waiting for us to migrate over to it. So we'll now go to our VMware Site Recovery Manager. This is the solution we chose for our server and storage failover. It has allowed us to pair our server clusters with the SANs. And in order to complete the failover, we must run our recovery plan, which is named RP1. And since there has not been a true disaster, we'll be selecting plan migration as to not harm any of our configurations. So we'll go ahead and run that. And in the meantime, this will be running in our background, but we're going to jump back to our slides.
So vCenter Server is a centralized management utility. It allows you to view and control all of our connected servers from one user interface. It allows for the management of the shared storage, virtual machines, as well as many other ESXi configurations. It can be used to assign permissions that restrict access for certain users. So each customer would only be able to view the data that they are allowed to access. And for this project, we deployed vCenter Server at our production and disaster recovery sites. This allowed us to cluster and manage all of our servers at each location. We also created different test users, gave them access to different data, which we will show later on in our live demonstration.
So for this project, we chose to use asynchronous replication as opposed to synchronous replication due to the fact that asynchronous has a lower bandwidth hit than synchronous, which is needed for any of the data traffic that's replicated over the WAN. Asynchronous replication works in that any servers at the production site write any of their data to the production SAN, and then the production SAN is able to communicate with the disaster recovery SAN to replicate any of that data that is missing. And then the server is able to just keep continuously writing to the production SAN, and then it will talk with the disaster recovery to update any of that data. We also had to configure server and storage failover as a part of this project. This allows for critical services and data to remain accessible in the event of a disaster recovery scenario. This reduces any impact on both the end users and the administration, IT staff. That way there's to make sure that everyone is up and running. We were able to implement this by creating both primary and secondary volumes on the SANs, and we're able to cluster our servers within VMware and use VMware's Site Recovery Manager to implement our failover.
So pfSense has a feature built in called DummyNet, which will allow us to use traffic shaping to put 50 millisecond limiters on our network. To do this, I can apply the limiter to an interface or route. In this case, I applied it to each network route for the SANs. This way, any traffic between the SANs will have the 50 milliseconds of latency applied to it, but our management will stay normal and unlimited. This allows us to simulate the WAN environment without having a physical WAN environment.
So now that we've discussed what we configured and why, we'll be going back to our recovery plan to see if it's completed. So as you can see, it says recovery complete. Everything has been successful. And just as a side note, if you wanted to revert back from this failover, all you have to do is hit reprotect. So we're going to jump over to our disaster recovery server here. I'm just going to refresh this. As you can see, the Windows server is now green, which means it is on. So we're going to go in here and we'll verify that the video is still there. But because it did power off, it is not going to be currently running. So as you can see, the video is here and we are going to be able to play it when it loads. Yep, so there's the video. And to further prove to you that it did work, we're going to go back over to our production server where you'll see that it is powered off over here. So it did move over. We'll now jump over to our SAN data collector, which is how we configured both of our storage networks. We're using Dell Storage Manager. As you can see on the left side, there's both of our storage centers. We'll be walking through the disaster recovery with you. Sometimes it takes a second here, so we'll just let it load. There we go. Okay, so this is our disaster recovery SAN. As you can see, it is up and functional. I'm going to click over to the storage tab where we can see all the different things we configured here. So I'm sure it's a little bit small and I apologize, I'm not able to zoom in on this. But as you can see, there's the volumes here. So these are the ones we created on the DR SAN. This is the replication of the SAN live demo, which is what that virtual machine we showed you is running off of. You're able to pair each volume with a server. So these are two DR ESXi servers we have running. The remote storage center is connected via iSCSI to the production SAN. And down here we have our fault domains, which allows us to segment our network and not have a single point of failure. So we're going to jump over to replications and live volumes. Here you can see all the volumes that we have replicating currently. And if we go to restore points, the SAN live demo, the one I said that the virtual machine that we migrated was running off of, now says DR activated, which again shows that we did indeed fail it over. So one other thing I want to show you is the snapshots. So the way that the replication works is each volume takes a snapshot. And we have a schedule set that every day at midnight, all of our volumes get snapshot and they replicate. But what I'm going to show you is that when we hit run on that recovery plan, it took a snapshot. So as you can see, a few minutes ago when we hit run, it took a SRM failover snapshot. And also as a side note, you can see that we did meet the RPO and RTO for this project, as it only took about 3.5 minutes to fail over, and we did not lose any data. Now we'll jump over to the vSphere web client where Ben will explain to us his part.
Okay, so today I'm going to show the vCenter server that we have deployed at our production environment. As you can see, this user interface gives us control over pretty much everything relating to our servers. We've added both of our Site 1 servers to a cluster, which you can see along the left-hand side, along with all of our virtual machines at our production site. I'm not going to go into too much detail, but just to show you around a little bit, across the top you can see all the different changes and configuration options you can make to the cluster. Another part of our statement of work involved creating separate users and permissions so that individual customers could log into vCenter and only access the VMs and storage they specifically own. So right now we're logged in as the administrator, so we can see all the VMs, but now we're going to log out and we're going to log back in as a customer just to show that they have more limited access. So right now we're logging in as customer 3, which should only have access to the 2 Windows Server VMs out of the group that we saw listed earlier. Yep, so as you can see, this user only has access to those 2 VMs that we specifically assigned to that user. And with that, that concludes our live demonstration.
Just to kind of wrap up and conclude on how we're able to meet the needs of Kersnuffles, we're able to configure both server and storage failover over asynchronous replication that meets both the RTO and the RPO. We are able to securely configure customer access via vCenter and only allow certain customers to see the VMs that they should. And then we're also able to implement a simulated 50 milliseconds of latency via our pfSense box. Here is our graph of our different hours worked throughout the project. As you can see towards the middle there, it kind of leveled out for the it kind of dipped for the different weekly hours, and that was due to our spring break and then our switch into entirely remote working. So that did present some challenges, but we're able to pick up the hours towards the end. And to make up for that, we did have a very big spike last week as we were trying to get boot from SAN working, but that was eventually removed from our statement of work. And we finished the project with just under 415 hours.
Now going into some of the challenges and roadblocks we experienced throughout the semester. There were quite a few that we encountered at the beginning of the project. The biggest challenge for us was our lack of understanding of the Dell EMC and fiber channel networking equipment. This was eased by finding the proper guides and with the assistance of our sponsors. The next challenge presented was our lack of storage infrastructure knowledge. None of us had ever touched a SAN before, so we knew there'd be a pretty steep learning curve. After many meetings with our sponsors and hours of research, we were able to start understanding the infrastructure and build our own network. Another challenge within this, as Riley mentioned, was configuring boot from SAN. We were able to configure it successfully for fiber channel, but ended up getting it removed from the statement of work due to the timing of the project. In addition to these, 2 other challenges were the worldwide pandemic and lab access. Having to switch to completely remote work presented its own challenges, but at the same time created a learning opportunity for our team. We configured things we would not have had this not happened, such as the iDRAC on the servers. It was great for us to learn this, and it helped us to learn how to use that versus relying on a crash cart in the data center. And lastly, a roadblock we faced was communication and expectations. This refers to the class as a whole, internally as a team, and with our sponsors. And we overcame this by asking a lot of questions and constantly seeking feedback.
Just to kind of touch on the different lessons we all learned throughout this project, for me, one of the biggest ones we first noticed was that the difference between Dell networking equipment and what we're used to in Cisco presented some different hurdles that we didn't think would be an issue, but we were able to find resources and talk to our sponsors in order to get the right commands and how to configure that equipment. And then that, especially with a project like this, management of it is more behind the scenes, but is definitely appreciated in the long run and able to get a successful project completed.
One thing we also found out pretty early on was how important it is to effectively communicate with your sponsors and just let them know when you're running into problems. I think this was really helpful in solving quite a few problems throughout our project. And we also learned the challenges of working entirely remote. as I'm sure we all did. It slowed down our progress a little bit, but now that I think we're all a little more prepared for situations where we might have to work from home in the future.
I found when working on a project where you don't have a good grasp of the technology, it is really important to reach out and ask for help because sometimes you can't Google the right answers. An example of this is when we were having trouble initially with the Dell networking switches, and Googling was not getting us anywhere, but Cyrus was able to help us, another Dell employee, get the right OS for our switches.
One of the lessons I learned was that remote work presents its own challenges and advantages, but the most important lesson I learned was just to keep moving forward. With all the roadblocks we encountered, it was not easy, but it was important for us to keep moving forward and focusing on our end goal.
So we want to give a thank you to the Dell EMC team for all of their time and their hardware donations, the CNIT program for reaching out to these organizations and helping sponsor Capstone teams with real-world situations, and the UW-Stout for providing the education opportunities in CNIT and other programs. And now, are there any questions?
Great presentation, team. This is Steve from the Dell team. I'm curious if anything was considered for automation, right? If this were to happen at 2 a.m. in the morning, how are you going to reach that RPO and RTO?
I can answer that one. So although, like, as you were able to see, it was not an automatic failover for the servers, but I was looking into it a little bit and I found that there are some scripts that might be able to be run. And also, if we had live volumes and synchronous replication, I believe that would also help to automate the process.
Hey guys, this is Mark with Dell. Just building off of that same question. In the event of, say, a network failure on one side, is your environment set up to effectively take care of that, handle it, and how so?
So if, let's say, one of the switches went down, we have a bunch of redundant links on each site, as you can see in our topology. The SAN also had that with the top and bottom controller, which we did test that at one point. So if you do take down one of the controllers, the other one picks it up and does all the work. As far as overall, because we only had the one switch in the middle for like our simulated WAN, this would not be like the best solution. So in industry, you'd want multiple switches, and then in that case, it would automatically pick it back up.
Yeah, and to add on to that, in a realistic situation, we wouldn't have pfSense running on a server that's in that failover cluster. It would be its own box, or we'd have a physical router like a Cisco or other device.
One other question to add on that. Did you guys find any way of setting up for like notifications for things that you may not have accounted for in the failover process?
From what I did, I know has an email notification that would alert you of errors. I'm not sure if we set anything up with vSphere. Ben, do you know about that?
Yeah, not that I know of. I'm sure there are abilities for vSphere as well. I think there's high availability and stuff, which we didn't set up, but that would obviously be able to do. I think email notifications as well. Yeah.
Any other questions for Dell team? I really like your demo. I think it's a very clever way to set up. You know, you have videos and then you go over to the other disaster recovery site. That's awesome. Good job. I also, yeah, I want to say Dell actually has the longest history of supporting our Capstone team for past 10 years. I think it never missed a single semester. So thank you so much for Dell advisors. You know, before it's always Jacob and Steve. I think this time is Mark and Mike, right? They kind of like a lead. I just want to thank them for their support and commitment. You know, I know they help you guys troubleshoot a lot. You know, thank you so much. Yeah.